So, Vinny, you can start now.
Okay. Good evening, everyone. I'm Professor Vinny Rautre from NIT Rourkela, and on behalf of all of us, I would like to welcome for today's talk Dr. Sonam Sandeep Das, who is an alumnus of College of Agriculture, Engineering and Technology, Bhubaneswar, from the 2014 batch. He obtained his M.Tech in Soil and Water Conservation Engineering from GB Pant, University of Agriculture and Technology, Pantnagar in 2016, and his PhD is in Water Resource Engineering from Indian Institute of Technology, Kharagpur, in 2021. Dr. Das currently is serving as a postdoctoral researcher at the King Abdullah University of Science and Technology, Saudi Arabia, where his
I think Sonam, Vinny is somehow muted. You can
Yes,
start with, you can give your own introduction and you can start.
yes, sir. Yes. Thank you, sir. Yeah. So, good evening, all my respected teachers, seniors, and juniors. I hope my screen
benefits
is
in
visible.
the
Go ahead, sir.
Uh, Yes, sir. Uh, so I'm Dr. Sonam Sandeep Das. I did my bachelor's in agricultural engineering from Odisha University of Agriculture and Technology. Then I did my master's in soil and water conservation engineering from GB Pant University of Agriculture and Technology. Then I finished my PhD from IIT Kharagpur in water resources engineering in 2021. Following to that, I did 2 years of postdoc in University College Dublin, Ireland. Since January 2024, I'm currently working as a postdoctoral researcher in King Abdullah University of Science and Technology, Saudi Arabia. Uh, Thank you for the opportunity to present my research in this platform. So today I'm going to discuss about modeling reservoir sedimentation in a broader context insight for agricultural engineers. So in this study, mostly I'll be talking about my current national skills study across all the dams I performed in Saudi Arabia. So these are the topics I'll be covering mostly in the presentation. We'll be discussing about the fundamentals of reservoir system, what are the components, how reservoir sedimentation happens, what are the overview of reservoir system in Saudi Arabia, and we'll be talking about the methodology I adopted to analyze the current sedimentation scenario across the dams. Then I'll be talking about the approach of reservoir bathymetry survey and corresponding scopes out of that. And in the end, we'll be talking about the current scenario of Indian reservoirs and what is the broad scope that an agricultural engineer can explore in the context of reservoir operation. So as we know, a dam are the large critical infrastructures in water sector. They are designed to block and store surface water both in long term and short term. So the figure below is a picture of the third largest dam of Saudi Arabia, the Baysh Dam. And usually the dams perform five major functions like domestic or drinking water supply, flood control, groundwater recharge, hydropower generation, and of course, irrigation water management. When we look at the anatomy of a dam, so broadly, it consists of five components. So the first, it starts with the water, accumulated water behind the dams, that is called reservoir lake storage. Then we come to the structural component of the dam, the crest of spillway, the body of dam, the downstream water, and then the spillway, which governs as the control outlet for dam flow. When we look at the different level of storage components that are generally assigned to a dam for the sake of operation, we see major six storage components. So the normal pool level that starts from dead storage, that's the lower level of dead storage, and the minimum normal pool level is the upper level of dead storage and active storage, and minimum pool level is the lower level of the active storage. And it starts with the dead storage, which is essential for maintaining the reservoir structural stability, and mostly sedimentation happens in the dead storage region. And above the normal pool level, we have additional storage that is meant for flood control. And on top of that, we have freeboard, which is called the surcharge storage. So depending on the water availability and the requirement, the dams, these levels are maintained, and accordingly the spillways are operated. When we look at the reservoir sedimentation dynamics, whenever a large flood event or flow event occurs in the upstream of the dam catchment, it carries varieties of sediments along with the water. So they may be bed load, they may be suspended load. When we look at the dynamics, so usually the big particles, which is called as maybe the gravels, they are deposited in the beginning of the dam lake area storage, creating a delta. However, the suspended load is more pronounced exactly near the spillway or near the dam. That we can clearly see from this figure. Coming back to the reservoir system in Saudi Arabia. So hypothetically, Saudi Arabia is famous as a country of no natural river. However, because of the wadi or valley system, it creates a indirect source of water storage in the form of wadis. So on that context, we can see the red dots here corresponds to the dams that are present in Saudi Arabia. As we know, a major part, like the central and central eastern part, is the desert part. However, the southwestern part, where we can see a dense distribution of this dam networks, this is having proper vegetation, having more than 50 days of annual rainfall in a year, and of course high slope region. So that's why the distribution is not highly uniform, rather it is confined to some specific portion of the country. When we look at the combined storage capacity of the country, so all these 574 dams nearly constitutes 2.6 billion cubic meter of dam storage. So when we look at the sedimentation scenario in the Saudi Arabia, this is a visible sedimentation happening in the one of the major dam in the Saudi Arabia called Jizan Dam. We can see here the visible lakes, or we can say some small vegetations are already developed inside the primary dam storage. And our preliminary assessment from the study that I'm going to discuss in the upcoming slides, also from the confirmation from the dam authority, says since this is the 10th largest dam of the country, but it almost lost 90% of its capacity in the current state. So this is highly concerning. However, it is not possible to look at all the dams individually by both field measurements and models. So considering this complexity, we took a pilot catchment where we can have all sorts of observations and instrumentation. So we took the pilot catchment as Wadi Baysh catchment that consists of nearly 18 dams. So when we did a visit to the dam, and I'd like to mention Saudi Arabia, although it's a developed nation, but it is highly data scarce country. They don't have any meteorological observation, no hydrological observation as well. So we found out an indirect way on our own to measure the current sedimentation scenario in the dams of Baysh catchment, the pilot catchment. So those dams which are nearly empty or dry, so there are some staff gauges mounted to the dam wall. We can see then based on the observations, we analyze the current storage scenario of the dam. So which says mostly the existing capacity of these 18 dams range between 34 to 54% across the pilot catchment. These are some of the specific observations that we found during our trip to this pilot catchment. This is one of the wild reservoir in that catchment with a capacity of nearly 1 million cubic meter. So currently it has only 43% of its capacity left. This is another dam in the pilot catchment having just 39% of capacity left. So we can clearly we can clearly see how concerning the scenarios are. As I mentioned, there is no proper hydrometeorological data available. So we also did an initiative in the current study to have instrumentation setup for this pilot catchment. And I'd like to mention, so this was a successful mission, and now we are extrapolating this instrumentation approach to the whole nation. These are some of the water level sensors that we installed to monitor the flood scenario, flash flood scenario. Also, we have some pressure transducers and turbidity meter to look at the sedimentation scenario. Now going back to the study that I'll be discussing mostly, the sedimentation in Saudi Arabia's 574 dams. So assessment using remote sensing and erosion modeling. So we adopted a threefold multifaceted approach. So where we'll be looking at the dam condition from the top, side, and the bottom. So when I'm referring to the top, so I'm talking about the lake storage behind the dam that will be assessing using remote sensing or satellite imageries. From the sides, so it's since I mentioned the flash floods are the major drivers of sedimentation into the dams. So from the sides, by instrumentation and the installed equipments, we'll be looking at the incoming flash flood into the dams. And from the bottom, of course, we'll be doing explicit bathymetry measurement to quantify the amount of sediment deposited in the dam in the current scenario. So in the integrated approach, so out of 574 dams, so since we are relying on satellite-based approach and our approach is based on Landsat imagery, so we cannot monitor very small dams. So we had a user-defined threshold of 0.1 million cubic meters. So any dam having more than 0.1 MCM storage capacity, we filtered 488 dams out of all, and we used Landsat imagery for a period of 1984 to 2024 to look at the trend and changing water extent over the dams. Then we used revised universal soil loss equation to model what is the existing sedimentation scenario across all individual dam catchments, so that we can have a quantitative measure of sediment loading into the dams. Of course, we integrated Russell model with a sediment transport equation by Baysh. And third, approach was to identify which is the potential driver that's governing the sedimentation issue across all the dams. So first, we will look at what is the existing trend in the satellite water extent for the dams. So as we can see here, blue points refers to increasing trend and red ones refer to declining water extent trend of the dams, and the gray ones having no trend. So from the 38 years of analysis, we found a median decline in water extent trend of minus 1.5% per year. And surprisingly, 63% of the dams are exhibiting declining trend. Out of those, nearly 147 exhibiting significant decreasing trend, which is truly alarming. However, the increasing trend is very minimal. The increasing trend is only observed in 12 dams. Then when we look at the drivers, so we broadly divided this drivers of sedimentation under four major heads. So one is climatic effect. Second is soil erosion effect. Third is geology, and fourth is water use. So first we look at the impact of climate in describing this water extent trend pattern. So we picked two important climatic driver, like the change in precipitation for that period and the change in open water evaporation for that particular dam. However, when we perform the correlation, when we look at the trend comparison to the decline in water extent trend, the median trend in precipitation and open water evaporation are very less. And so they are not adequate enough to describe that significant minus 1.5% decline in the water extent trend. So we extended this approach further by creating a spatial correlation between water extent trend decline with precipitation change and open water evaporation trend. So we found counterintuitive trend. So that corresponds to the fact that climate variability is unlikely to be a primary driver of reservoir sedimentation. in Saudi Arabia. Then we went for soil erosion to look at the impact of soil erosion on this declining water extent trend. So as I discussed, based on the Russell approach, so we derived the soil erosion status for individual dam catchments. Accordingly, we estimated sediment yield by integrating the Russell with a sediment delivery ratio equation. And lastly, we derived what is the sediment infill time. We can see the red dots represent infill time of less than 20 years, which is truly a concerning point from dam management point of view. The mean erosion status across the country was found to be 12.1 ton per hectare. And based on that mean erosion status, we have a median infill time for the whole country is 43 years. When we compare this starts with a global estimate, the global estimate says the mean infill time is 100 to 200 years, which is nearly 1/5 of global scenario, which is highly concerning again. And also, when we compare this erosion model estimate with our satellite-based estimate, they're very much close, as suggested from the median estimate of 66 years. Then we further extended the spatial correlation between water extent trend and soil erosion. Although we are getting a small positive correlation, however, this positive correlation somehow points towards the role of soil erosion or sedimentation in controlling the reservoir water extent decline dynamics. However, this weak correlation may be subjected to parameter uncertainty and using multiple sources of data. Then we went for looking at the impact of water use on this water extent trends. So when we look at the water use trend of Saudi Arabia for the period 1970 to 2024, we can see agriculture is the major water use, nearly accounting for 84% of the whole water use. However, since Saudi Arabia is focusing on mission Vision 2030, where they are prioritizing the water reuse, so after a period of 2010, so they are more into recycling of water. So there is no significant water drawn from the reservoir. So nearly we can see it is constant, and the withdrawal for domestic and industrial is negligible as compared to agriculture. So this points at the fact that there is no excessive dependent on reservoir water use. So that may not be the reason behind the decline in water extent. Then we went to look at the geology of the country, whether geology has any influence or not. So this is a course resolution geology map. Still, it consists of more than 10 classes. So when we look at the correlation between the geology classes with the water extent change behavior of the dams, so only the siliciclastic sedimentary rocks, which possess a moderate erosion potential, exhibited a spatial correlation coefficient of negative 0.38. However, no other class exhibited any sorts of correlation. So this also points geology, of course, is not a primary driver of the sedimentation in Saudi Arabia. Then with this confidence, we try to extrapolate the current scenario to the whole country. So what we found is really interesting and alarming for the dam managers as well as the Ministry of Water Resources Saudi Arabia, because when we combine the capacity, we can see a clear gap of 32% in the design and actual capacity. So 1/3 loss in the storage capacity is highly concerning. And I'd like to mention this project is directly inspected by the Ministry of Environment and Water Resources Saudi Arabia. They are now looking at our results to implement proper management solutions for the recovery of this storage. So to conclude this study, I'll say yes, 63% of the dams exhibiting declining trend. More than a quarter may be completely filled with sediment if we look at the period 1950 till now. And there is a very good agreement between satellite estimate and model estimate, also with the in situ estimates that kind of provide confidence to the assessment on the national scale. More detail can be obtained from this paper that we published recently. Now I'm going for a more interesting fact about bathymetry analysis. So as I said, there is no data. We tried initiative of our own to look at how the bathymetry or how the sediment is accumulated across all the spatial storage area of the base dam, which is of course in the pilot catchment. So we implemented a USP based ultrasonic beam echo sounder to measure this. We can see on the left, those yellow and purple lines shows the trajectory, how we did the bathymetry survey on the date of 26th February. And on the survey date, we have a 3.6 kilometer square of water extent area. And the right plot here shows, based on the survey, it says the current water depth in the dam. And we further used this dam with the integration of a 10-meter DEM to develop the volume area curve for the dam. When we compare the bathymetry based volume area curve with the when we compare the bathymetry based volume area curve with the design curve, so what we found that is very critical that points towards a very critical result. So the design says, corresponding to a design area of 8.2 square kilometer, the dam has a design volume of 198 million cubic meter. I'd like to mention this dam is being constructed on 2009. So when we look at the capacity exactly after 16 years, so now the bathymetry survey reveals the design volume is just 127 million cubic meter, corresponding to 7.72 square kilometer of area. So also this bathymetry survey revealed nearly 20 meter, which is almost the complete date storage of the dam is gone. That certainly challenges the structural stability and the operational accuracy of the dam. And yes, so at the current state, nearly 36% of the original capacity of the dam is gone. When we look at this finding in a future scenario, what we see uh, based on the simple extrapolation, in the next 30 years, the third largest dam of the country is going to be filled fully with sediment. And the most commonly used storage level for this dam is less than 48 meter. That gonna vanish in the next 17 years. And also when we compare the bathymetry based analysis, which is certainly the most accurate one, with our model based analysis, the lifespans are very much close. Of course, this sorts of discrepancies is expected when we work on a big scale with satellite imagery. As we identified, sedimentation, particularly flash flood driven sedimentation, is the major issue in Saudi Arabia. So we are developing our own flash flood early warning system. So as a part of that, this thing is currently under progress. So lastly, I'd like to discuss about the reservoir sedimentation issue currently in Indian context. So if we look at the Indian context, in the very recent survey by CWC says India already lost 1.7 billion cubic meter of its reservoir storage capacity, which is nearly equivalent to loss of 10 to 12 full-size dams in every decade. And that is concerning. Again, when one more interesting fact that we found from a recent literature, the total incoming sediment load into the Indian reservoirs, so nearly 70 to 80% of the total sediment loading is confined to just 20 days of the peak monsoon events or extreme events. So extreme events are causing the maximum reservoir sedimentation issue in terms of rising flash floods, which is particularly pronounced in the Himalayan region. And currently, when we look at the statistics, India has already lost 16% of its total life storage capacity. When we look at all the 5,300 dams of India since 1960, in a future scenario, CWC also says by 2050, India is projected to lose nearly 35% of its total usable storage capacity, which is nearly 10% higher than global average of 26%. When we look at the figure below, so that says how India stands when we compare it to globally. So a global average of sediment loading is just 300 ton per kilometer square per year. But when we look at the Indian context, a basin in northeastern part or maybe in Himalayan region, they reach a value of 1200, which is nearly 4 times of global average. So that says the reservoirs of India's vulnerability to this particular issue. Also, when we look at the current capacity of many of the dams in Odisha as well as in India, we can see the Kolab Dam of Odisha that has lost 44% of its live storage capacity, which is highest in Indian reservoirs, followed by Hirakud Dam. Hirakud Dam lost nearly 28% of its dam capacity, and we all know the dependency on Hirakud Dam, not only for hydropower, also for irrigation. So if we're not gonna adopt adequate steps to monitor it in a high frequent manner or in real time, the situation is going to be more worse. Yeah, looking at these things, I believe there lies a great scope for agricultural engineers to explore this research area. As we know, agricultural engineers are the main end users of this reservoirs. So of course, we have a very good expertise in watershed management. As I mentioned, of course, the upstream catchment is the major culprit that drives the sedimentation from catchment to the dam. So we should begin with a watershed management strategy. We should look for some economical, yet viable and effective strategies like check dam, terraces, where it can be incorporated. Also, instead of this structural measures, as an agricultural engineer, we should promote some nature-based solutions like sustainable land use adoption, forestation, maybe contour farming. Also, this study, what I did, I explored, of course, satellite-based in studies can be very easily implemented across national scale. So with further refinement, we can develop a proper real-time sediment reservoir monitoring status, not only for sedimentation, also we can instruct the dam manager to operate effectively in real time. And the last one, we can also promote sustainable irrigation to reduce runoff that can also check the sedimentation scenario in the dam itself. Thank you. That's all from my end. Thank you.
Thank you, Sonam. That was a very engaging talk.
Thank you, ma'am.
The floor is open for questions. If anybody wants to ask any particular question to Sonam.
Hello, Sonam. I am Prabhas Samal speaking.
Yes, sir. Thank you.
We all know that Saudi Arab has no river. Then
Yes,
how
sir.
many dams are there in Saudi Arab?
So there are 574 dams, and all of them are wadi-based dams, like from the valley-based erosion runoff.
If wadi-based dam is possible in Saudi Arab, then can it be possible in Maharashtra? Because Maharashtra is famous for wadi management, what I know.
Yes, sir. All of the dams are wadi based, considering the large slopes that is confined to the southwestern part of the country. So yeah, but the main issue with wadi based dams is that they're not feasible because, as I mentioned, here the sedimentation statistics, when we compare this with global statistics, why it is nearly threefold or fourfold, it's because of this wadi system. Because the wadi system creates more sedimentation as compared to the Indian context. So it can be feasible, we can create, but it will be very difficult to monitor. Yeah, it will be expensive.
We all know that in Maharashtra,
Yes, sir.
especially the area where there we find always drought. The number of dams in Maharashtra is highest in the country, but the dams never get sufficient water due to less rainfall, and irrigation is a problem in Maharashtra. Perhaps all of us know it. Okay, thank you.
Thank you, sir.
So
Thank you, Dr.
Oh yeah, okay. Sorry.
Yes, sir. Please proceed with the question. Yes.
Yeah, so I'm very curious about your UAV that you have used. What kind of sensor did you use to estimate the bathymetry? You said something like a sonar.
Yes, sir. it is an ultrasonic sensor and it has a range of 100 meter. So basically it works on the concept of echo sounding. So it
Yes.
sends a signal to the bottom of the dam from the water level, and it measures the time of travel back to the sensor. So based on that, it measures, okay, this is the depth of water currently lying in that particular region.
So the penetration is 100 meter.
The range is 100 meter.
Possible penetration is 100 meter.
More than 100 meter as well. The one we use that has a range of 100 meter.
Okay. So and you created the mission. Okay. My curiosity is, you said geology is not impacting sedimentation. Um, Climate change is not impacting sedimentation. What was I mean, flash flood has to interact with geology, correct?
Yes.
If there is flash flood, it has to interact with geology. And you are saying the only siliciclastic, right?
Just take rocks.
Sedimentary rocks, those are the only ones that erode. Or with the flash flood, is that how it works?
No, sir. As I mentioned, the geologic map we use, that is not very fine. That is a coarser global map. So whatever geological analysis I'm saying, we are not very much confident, and we are not completely denying the role of geology. So when we look at the what we did, we estimated the percentage of different geologic formations in each individual catchments. So then we perform the correlation of each class with the water extent decline trend. So the siliciclastic rocks are mostly confined to the southwestern part of the country, and the erosion potential of siliciclastic rock is moderate. They're not very less erodible like metamorphic rocks. So yes, of course, the sedimentation is a outcome of, I mean, the age of sedimentation is an outcome of the geology of that region. However, the geology map we use is not that detailed. So broadly, we consider whatever rock types we have, they are having high erosion potential. So it's only the bed erosion, rather there is very less erosion from the rock types. So based on the soil types, we're saying the sediment is happening.
But the flash floods work, flash floods will carry the sediments through the reservoir through the channel, right? Or the
Yes.
channels that are feeding it, correct?
Yes.
So are there, is it due to the channel erosion, or is it due to the source erosion, is what I'm asking. Like, so let us say precipitation will bring runoff down to the channel, correct?
Yes.
And then the channel will carry the water, discharge the water and the sediment down to the reservoir. Okay. And even in the channel, yeah, flash flood will. So if there are flash floods, then the length of channels are pretty short, reaching the reservoir. Is that correct?
Yes, sir. When we compare to a regular flash flood that happen in India with Saudi Arabia context, so as I mentioned, these are wadi-based channels or wadi-based dams. The width of channel is not that high. They usually range from very small, like 2 meter to maximum 10 meter, 20 meter. The channels are not that wide. So whatever scouring that happens in the channel itself, when we look at the edges of the channel, they are supported by permanent rock types. So not many erosion happens from the rock types, rather the scouring happens directly on the channel, because we know the flash flood is one of the biggest issue in Saudi Arabia because of the permanent sealing in the soil. A very small amount of precipitation, let's say more than 20 mm, even if it happens in an hour, that can also create a large amount of flood volume. So that creates the scouring in the channel itself, not from the rock types.
Just for curiosity, what does wadi mean?
So wadi means in technical terms it is valley. So they are like two
I mean,
ridges.
is that an English term or an Indian term?
Uh,
Wadi.
Wadi, I mean, I heard this term when I came to Saudi Arabia first. Then I realized it's an English term as well. So wadi is valley.
Is
Bhai,
it?
Wadi. The Wadi means Wadi. It's a
Valley,
Urdu.
right?
Wadi,
Wadi
Wadi,
is
it's a
valley.
valley.
Okay. That's what I was suspecting because I never heard this word. Uh, acha. So, so basically, in order for erosion to occur from channel, uh, channel limits or banks or whatever it has to be fairly unconsolidated, correct? If it
Yes.
is not unconsolidated, then even flash floods cannot erode the
Yes.
banks of the streams. The other thing that could result from that is widening of the streams rather than deepening. Or maybe it's deepening, but I'm thinking is the deepening could go like in what I'm trying to ask is, did you observe any widening and deepening and what kind of unconsolidation is there, you know?
Yes, sir. As I said, during our field trip, when we look at a particular channel, because we already did a channel cross-section survey, it's mostly a deepening phenomena. Since the
Okay.
banks are protected by permanent rock types, so the scouring action from the banks is very minimal. So all the scouring happens in the channel itself. So it's mostly deep in the channel rather than widening.
Gully, deepening the gully. Okay.
Very less scope for widening.
Okay. Yeah, so I like the last slide. You know, you have provided some insight how
Yes, sir.
agricultural engineers can
Yes,
have a
sir.
role in this one. And I'll let others talk. I can come back later, you know, in this role of agricultural engineers.
Yes.
Any other questions from anybody else?
Yes, sir. Actually, I will just supplement some of the information and the question what Devu sir is asking. I have the answer. Actually, sir, in the whole Saudi Arabia, that wadi is actually it is defined as a dry bed river. So they do not have actually all their flows are mostly overland flow dominated, not the channel flow dominated. So when I think in Saudi Arabia, southwestern part is getting a rainfall of around 400 to 600 millimeter, and it is all hilly areas. So hilly areas means the base material is rock, and over that, from the catchment, whatever sediment is coming out, that is falling, settling in the that what is that river bed, dry river bed. And when there is a flash flood, all those sediments are coming into the dam. I think Sonam, you have to confirm if I am wrong,
Yeah.
if I'm right or wrong. So this is what is happening. So it is mostly overland flow, but only during the flash flood, all the sediments which are getting accumulated from different parts of the catchment, that is getting deposited over the dry bed, and then that is getting washed away along with the runoff water. This is what is happening in Saudi Arabia. And the rest part actually it is some 20 millimeter, 50 millimeter average, and whole Saudi Arabia annual average is 95 to 100 millimeter.
Yes, sir.
So this
Okay.
is what, and then this is happening. So that bank is already, sir, because of so many years. So that bank is all rocks which are not scouring, but from the catchment sparse area, all areas sediments are coming and putting coming to the driveway. This is what is happening. And wadis is mostly related to a Saudi Arabian word. So in Saudi Arabia, wadis are dry bed rivers. This is what is the definition says.
But Prabhat Babu just said
No,
that
no,
it.
no, no, no.
Yeah.
What meaning is that I am telling in certain Arabic speaking countries, a valley, ravine, channel that is dry except in the rainy season. Wadi name is there in our Maharashtra because in Maharashtra the soil conservation people they do all the soil conservation activities on wadis. That wadi concept has come to even to NABARD. When I was working in NABARD, they were developing wadi development, wadi based water management. So wadi what is there in India also, especially in Maharashtra.
Ram already has defined it. Right? You know, it's a Urdu or Arabic word. Wadi is valley. So instead of calling it gully, they call it valley. So that's okay. Um,
As
but
Sultan sir mentioned,
yeah,
like more than 95% of the river beds, they remain dry across the country, except whenever there is a flash flood event.
Any other question? If anyone has any particular curiosity.
Sir,
I think
another observation.
we are.
Let me
Yes, sir. Yes, sir.
supplement
Please
something.
go ahead.
Sir, actually,
Yes, sir.
Sandeep also forgot one observation which is happening with Saudi Arabia. There is a rainfall decrease from 1994, around 30 to 35 millimeter per decade. So there is a climate change effect in Saudi Arabia also. The rainfall amount is decreasing by 35 to 40 millimeter per decade, but the flash flood events are increasing. So there is a climate change effect in Saudi Arabia also. This is what
Yes,
Debu
sir.
sir was asking.
Yes, sir. I highlighted that point. When we look at the trend in water extent decline and the decline in precipitation, as I quantified in one of my slide, the decline in water extent trend is minus 1.5%. However, the declining rate, median decline rate of decline in precipitation is just minus 0.4% per year. So what I mean, what we interpreted, the rate of decline in precipitation is not adequate enough alone to describe the decline in water extent. Of course, there is a role, but that is not significant like sedimentation or soil erosion happening.
Yeah, but I'm curious, Sushant, you brought up a good point. So if the precipitation quantity or volume is decreasing, right, in a decade, I'm asking Sushant actually. So, I mean, this is a discussion now. We can ask each other. So, if the precipitation volume is or in decreasing, why are the flash flood intensity increasing? What could be the reason?
I think Sonam will be a better person to reply. Why? Because, see, sir, actually, what I understand with a little bit of reading is their southwestern part is completely hilly and undulating, and all those things are happening in that part only. Rest of the part there is very limited rainfall. So all these things are because of the topography and geographical location. Everything is happening. I think Sonam can supplement
Yeah,
to this
that's
observation.
because
Yeah.
of the orographic precipitation, right?
Yes, sir.
So it pulls the water from the sea and brings it, and at the orographic heights, it is precipitating. So that part is understood from a meteorological perspective, right? What I'm
Yes.
trying to say is, say this year the precipitation volume was 100. Next year it goes down to 80, let us say. Okay. I'm just taking an example here. If it is going down to 80 units, why is the flash flood increasing from, let us say, 10 to 20 in the subsequent year? There has to be a reason. Okay.
Yes, sir. So my supervisor here, he's a developer of precipitation products in a global scale. So what he analyzed, we tested multiple satellite and radar-based precipitation products because in Saudi Arabia we don't have any IMD like uniform rainfall system. So what we found, as Susan sir mentioned, like although precipitation is declined, but if we look at the change in trend in temperature, it is increasing. So that increasing trend in temperature, increasing the PET and subsequently it creating the high evaporative demand. So that evaporative demand is promoting to more extreme precipitation. So as sir also mentioned, the channels here are fully dry and the flow is mostly Hortonian flow or overland flow. So irrespective of the magnitude, it purely based on the intensity. So high evaporative demand creates high intensity storm, and that high intensity immediately creates a huge amount of flash flood event, and that brings a significant amount of sediment into the dams. So it's the increase in temperature trend causing that flash flood to happen.
No, the reason I brought up this discussion, you touched the right point, intensity. Okay. So
Yes.
essentially, the intensity, there are two factors, right? Intensity and volume, correct?
Yes.
Of discharge. So you studied the volume of discharge, not the intensity of discharge. Okay.
Yes.
If you had studied that, then you could have probably gotten a better correlation of why the intensity of a discharge is causing the um, erosion, increased erosion. Okay, of course, higher intensity of discharge, and then you can develop some kind of a model like peak over a threshold discharge. That way you can then study those peak events, as you said, extreme.
Yes,
So
sir.
looking at your whole analysis, I'm just getting back to the point that you probably should go back and reevaluate what are the peak over threshold
Yes, sir.
intensities that are causing this sediment release. Okay. And then second thing is, don't just say geology isn't contributing. Go and see what is the degree of unconsolidation that is causing this. Okay. If you
Yes.
and those can be easily studied by just taking a small core sample and other stuff. If you can access areas, you
Yes.
can see what is the degree of unconsolidation between the banks and the reservoir bed, and that will give you another, not reservoir bed, sorry, a stream bed. That can
Yes.
give you an idea about how geologically the flash flood is contributing to the sedimentation. So essentially you have to think out of the box and go and do that. But the remedial part, I don't know in Saudi Arabia what can be done. So I'm waiting for the remedial part. India, you
Uh,
gave a good example. Okay, but remedial part is not clear to me.
Yes, sir. So thank you for the suggestion. I'd like to mention actually, so the study I presented, that I performed maybe more than 10 months ago actually. When I joined there was no data, as I mentioned, no data is available. So this study is exclusively relied on satellite-based imagery as well as satellite-based precipitation product. And the limitations, what we identified, and when we identified there is a real necessity to monitor the scenario, particularly the flash flood scenario in real time. We also thought of developing a hydrological model for the whole country. So for that purpose, we tried evaluating all sorts of existing hydrological models, generally in practice, like SWOT model, VIC model for the country. None of them worked. Considering it's a hyper-arid condition, the conventional hydrological model performs very poorly. So what we did, we are currently we almost developed our own flash flood monitoring model. So we called it ROSH. So now we are running it at a temporal resolution of 10 minutes. Now we have real-time inflow information for all the dams across the country, and we'll be developing an early warning system. And regarding the management part, I'm also currently working, since the management is a highly subjective aspect, particularly when we work on a national scale. So I'm taking an initiative. I already did the conventional SWOT model setup for the whole nation. So now I am extracting the upstream catchment area for each of the dam catchment, and I'm trying to simulate the effect of performing maybe contour bonding, maybe contour farming. Are they really effective in reducing the sediment loading? And I'm confirming that in from some particular landscape evolution models. They are more physically based models. They account for sedimentation, like CJAR list flood. So they integrate a land surface model with a hydrodynamic model like list flood to give a more realistic insight about the detachment and transportation process. So soon I'll be concluding the management aspect as well. I'm exploring that thing now.
Yes. So, Sonam, may I simplify what Sir is expecting from you?
Yes, sir.
Debu sir is telling, let us have some meteorological observatory in those areas to see whether over the time, whether the number of rainfall events are increasing or decreasing, even if the amount is decreasing, whether the intensity of rainfall is increasing or decreasing, that needs to be studied to confirm that over the time, whether intensity has been increased or it is decreasing trend or whatever maybe this is one what he told actually pointed out, if I have understood correctly. Secondly, SWAT is not going to work in your place. Why? Because SWAT principle, it will try to develop the suppose drainage network. But in
Yes.
your place, there is no drainage network is there. It is dominated by overland flow. Then
Yes.
flow gets accumulated at one place. Then it starts flowing to the through the valleys. So this is what is happening in your place where the rainfall is 400 to 500 milliliter. In the rest of the areas, it is only infiltration rate is very, very high, and everything is going down and no channel is developed. So SWAT will not work, I guess. Maybe very small micro water sets of those southwestern part, it may work, but not for
Yes.
the whole country. It will not work. Then another thing is, in the last slide, I think Devu sir will say, otherwise I'll say, whenever we are projecting for 2050, we assume that business as usual. If you are not doing anything, then that is going to happen.
Yes, sir.
Because in between, we are doing so many things, so many interventions are being done by government agencies, NGOs, and so many implementing agencies are doing, working on it. So that is not going to happen. So whatever dim picture you gave for India, it will not happen to us. Don't worry
Yes,
for
sir.
us.
Yes, sir. Thank you, sir.
But why not, Sushant? I mean, I think that was a very uh, over or forethought, good forethought by Sonam for how agricultural engineers can contribute to the reduction in sediment loading, right? So essentially, he's already saying that I can try in Saudi Arabia contour vegetation and other stuff, which Israelis did very effectively. I mean, not for sedimentation purposes, but for other purposes, right? So if we can learn from them, even in India, people have done. I'm not saying that they haven't done. Go to in Prabhat Babu will say he has seen parts of India where people have done this kind of contour-based vegetation and other type of soil conservation measures in the catchment area to reduce erosion. So. So in other words, that at higher altitudes, trying to break down the contours in Saudi Arabia, particularly, I don't know what kind of process can be used because it's a completely rocky,
Yes.
because the unconsolidated materials have been washed off, definitely, out of those areas. So that was my question: is what kind of course, you may not have thought about it yet, but I'm saying in the future, if you can think about how, I'm not, I'm not saying you should not think about Saudi Arabia. Yes, Saudi Arabia, if they need more water, water is important for all of us. So, if you're thinking, how can you, I'm not saying that you try to fit a square peg into a round box. So just you use Russell, for example. Russell,
Yes.
how did you get the values of the parameters except the rainfall? So that's the question. Okay.
Yes.
So basically RKS, what is it? RKS,
CP.
RKLSCP, sir.
RKL, so yeah, I'm forgetting.
SCP.
SCP. So
SCP.
slope is okay, something else is okay, but those parameters are not really well established for many catchments, is what I'm trying to say. So you adjusted to those, right? So
Yes, sir.
similarly, looking at future, you can also think, how can I adjust my, or how can I develop my foresight in reducing the sediment load? Because prevention is always better than cure. Dredging the dam is not easy, it's costly, but preventing it from getting sediment
Yes.
load is uh, probably easier, in my opinion. Anyway, I'm stopping now. It's an excellent presentation, but I'll let others discuss and ask
Sir,
questions.
regarding geology, I have one point to make.
Yeah.
Sonam, geology will be always responsible when there will be any hydrological event wherever in any part of the world. Why? Because you see, all the metamorphic you are telling now, all the powders, all the sediments you are getting is that is only the eroding part of from the base material. So whatever your bedrock is there, that is getting eroded due to the rain and heat, because the temperature is very high in those areas, and then it is transformed into powder form, let us say sediments, and then that is coming along with the overland flow. So my point is, geology is always very, very responsible for all these geological activities.
Yes, sir.
And then what Sir mentioned, Debu Sir mentioned is that already is being done. Like they term it as catchment treatment plan. Instead of focusing on dam and reservoir, if you are focusing on catchment treatment so that it prevents the sediment to come to the valleys, to that valleys.
Yes.
So that maybe afforestation, maybe by vegetation, maybe by because base rock materials are there and it is very much undulating. So may not be trains and other things may or may not be possible. Why? Because the soil depth may be very less also. So you will have a better option for agroforestry, vegetation, or along with control, of course. So I think that we have not visited. You will be the best person to judge all those things. So this is what I want to come. Thank you.
Or you can sponsor this whole group to visit your, they're all experts here, to visit Saudi Arabia and or you can take Prabhat alone. He can. Uh, anyway, good discussion, and glad that you were in Dublin for a year. Uh, um, that's my favorite place in the world,
Yes, sir.
aside from India.
Yes.
I think that we can wrap up the discussion for today for Sonam, if everybody agrees. Um, Sonam, thank you so much, and it was very engaging. And thank you for having a very vibrant discussion. Also, means after the presentation, I would like to say, and excellent work till now. And we are very proud of your work, and keep doing the good work which you are doing right now. So, best of luck.
Thank you. Thank you. Thank you, sir.
Thank you.
Sir,
Thank you all.
sir, one
Thank you,
good,
everyone, for joining today.
sir, one
Namaskar.
good observation, sir. Today Sonam finished in 7:59 few seconds, and Winnie finished in 20:29. This much perfection in Indian actually participants may be unique.